Yeah. Hey everyone. Yeah, so I got kind of sick as I was making this talk, so I apologize for some of the slides. And also, if I lose my voice, I hope you can hear me in the back, but if I lose my voice, maybe I'll stop the talk or something like that. But so far, so good, right? All right, so late last year, I don't know if you guys remember, but Google came out with this Quantum AI lab. And I was puzzled personally. I was like, okay, what's the correlation between quantum and AI? So yeah, that was me. I don't know if you got it, but I was puzzled. So I came out with the ZK Quantum AI Lab, and I thought this would be really cool. A lot of people thought I was not kidding, so they reached out to know if they could join the lab and actually do some research with me. So I thought, okay, maybe I should do something like that. If I can hire good people and create some buzz, then maybe I should do it. All right, so we all know that AI is going to replace us. So I was thinking about, okay, if I do ZK and AI, that's my job, my job is to find bugs in ZK. And AI replaces me, what am I going to do? So I was thinking about eco farming these days. And actually I got a better idea because I heard this guy talking about AI, and apparently AI is not going to replace us. Apparently the person using AI is going to replace us. And so I was like, all right, I'm gonna be making use of AI. I'm gonna try not to get replaced by the person that's using AI. Yeah, it's probably an AI-generated image. The first thing I could find on Google. All right, so from there on, these were my best slides. Everything after that is pretty bad. As I said, I couldn't really do nice slides like I like to do. So maybe don't look too much at what I wrote and follow my voice. So okay, so I was like, can I find ZK bugs using AI? And the quantum part, maybe we'll find out afterwards. And I know for many years I've been in this field trying to find bugs and doing security and so on. A lot of people talk about static analysis, but it's sort of well known that static analysis is a lot of work and doesn't work well. And as you do a lot of work in one framework, but then you try to change framework, and then you have to throw all the work that you've done. It's very hard to translate some work that you've done in a different place. And so with AI, it sounds like you make it work for one thing, and then it's very easy to make it work for different languages and frameworks and so on. So, okay, so this is my last good slide actually. I put some work here. So I'm not really an AI expert, and I was kind of like fucking around. I was trying to do this kind of thing. So I think this talk is mostly going to be useful if you're an AI noob. And if you're an AI expert, you might think, what the fuck are you doing, David? But this is great for me, because if you're an AI expert, or if you know better, AI more than me, then maybe you can you can correct me or give me some ideas, and I can improve this stuff I'm working on. And maybe I shouldn't ask, because that's going to be bad if everybody says that they're an AI expert, but just to get an idea. On what's the crowd here? Raise of hands, who has run a local LLM before? Okay, so maybe 50%, maybe a bit less. Who knows what RAG is? Almost 50% still. Who knows what a distilled model is? Okay, so I guess half of you are not going to get much from this talk, but the other half is going to learn some stuff. Okay, I'm gonna talk about a lot of things, so maybe you're gonna see some interesting things. All my proof of concept was done around Circom. If you don't know, Circom is this ZK library, ZK language to write circuits. It was just easier to work with Circom. A lot of the circuits a lot of the projects we look at still use Circom. So I would say it's the most popular framework to write ZK circuits. And my idea was that if it worked for Circom, it's going to work for a bunch of other stuff. So the naive approach was, okay, what if I paste all the code that I'm looking at, and I try to prompt it like, okay, you're a security engineer, and you try to find bugs, then maybe it will work. And we have pretty large context windows nowadays. So Gemini is 1 million tokens, I believe, or I don't know what's the last version. A lot of the models are like 128K tokens, so you can actually paste a lot of stuff in one prompt. It's pretty good at that. And then I was thinking, as my company is called zkSecurity. We do a lot of audits, so we have a lot of bug reports, public or private. And so maybe we can paste that also in the prompt and give some guidance on how to find bugs in Circom and these kind of things. And maybe that can work. You know, that's the naive approach. And yeah, obviously I want to find actual bugs. That's kind of my goal here, is to try to see if I can you know, find real bugs just using AI and you know, tell you guys that I found some AI bugs, some ZK bugs using AI. And also I want to automate things because, like, you know, creating a prompt myself, pasting it into ChatGPT or Gemini or like whatever, it's kind of time consuming. It's not a really good way to do things, so I want to like build something. Just for the half of the room, I guess, that doesn't know too much about AI, when I'm talking about tokens and what is it, like this context, this I guess the word, this context window or token window, I can't remember. Basically, you can think of like a word is a token. Sometimes you need multiple tokens to form a word, or vice versa. But it's a good approximation to think of one word equals one token. So that's the size of the prompts that you can give to the AI. If your prompt is bigger than that, then it doesn't work, and then you have to cut it in a smaller prompt. And it's sort of, I don't know if you can read that, but that's sort of the prompt I started with. There's nothing fancy. Probably you could have come up with that if you were on your first try. Yeah, if you can read that, it says you are one of the best security consultants on planet Earth. That's the first thing I wrote, right? Don't judge me. You are in charge of analyzing the following Circom code. Then I pasted a bunch of code. And then I included all the dependencies of the code. So I had to manually do it. It was kind of a pain in the ass. And then I said, okay, focus on soundness bugs, completeness bugs, logic bugs, and here's some more help. And here I had a bunch of bug reports and documents and stuff like that. So it kind of sucked at first because the prompt size was pretty big. I put a lot of code in there. So my first instinct was like, okay, I need to reduce that prompt. Also, I read that if your prompt is too large, you don't really get good results. They did a lot of research on like Gemini and like these large prompts where if you paste like the entire, like a book, and you're trying to query something in the book, then you'll find it. But for a bit more like reasoning kind of things, I guess it's called like needle in a haystack test. But for like more, you know, real thinking kind of things, then it doesn't work that well, apparently. So I was like, okay, I guess I need to reduce the amount of code. I'm just gonna paste the code that's relevant to me, like maybe like I'm just analyzing a function. And I'm gonna create also the documents that are interesting to me. I'm not gonna paste all the bug reports that I have. I'm gonna try to only bring in the ones that are relevant. So, but yeah, some other people might think that actually no, you shouldn't try and like curate your prompts or like curate documents or whatever. Large prompts are the future, so there's kind of two camps, and we can try and find two different approaches here. So okay, so what I'm going to talk about next, a lot of the things I'm going to talk about is how I managed to reduce that prompt or make it more relevant. And so there's manual creation. I can do things manually. I can use static analysis, but as I said before, again, sucks. I can do fine-tuning, or I can do RAG. And so I'm going to explain these things. If you don't know what fine-tuning and RAG is, don't worry. I guess I'm going to start with fine-tuning. So fine-tuning is basically, you take the states of the model. So not all models are open source, but there's a bunch of models that are open source. I guess they're called open weights. And whenever you get a model that you want to use for inference, to generate some text, what you get is the state of the model. And I guess it's not like for me, I thought it was like a cryptographic hash function where if you get a digest, or if you get something, you can't really get back to the state, so you can't really use it. But no, if someone gives you the model, you can actually use it and you can continue training it. So it's like, yeah, I don't know if that's useful, but. So fine-tuning is like you take a model and you continue training it. You can use APIs to do that, or you can just download one of these open source models and do it yourself. So one idea is to fine-tune your model based on your code base. So if you have a specific code base that you want to be able to query, or you can fine-tune it on Circom documentation or on Circom bug reports and these kind of things. Yeah, don't read too much into that. I guess that's mostly for me. But the primary fine-tuning is that apparently you need a lot of it, a lot of data for it to be useful. So you really want to alter the state of the LLM. And so if you only use a few shots, it's not going to work well. And the other thing that really sucks is that as soon as you change model, you have to re-fine-tune it. So if I want to try different models, or if there's a new model that comes up, so yesterday or 2 days ago, like O3 came up, so I was happy that I didn't use fine-tuning because I could quickly change and just use O3 mini from ChatGPT, from OpenAI. So fine-tuning is kind of sucks. And I'm hoping that I don't have to use it. Maybe I'm going to talk more about fine-tuning later. But for now, I'm kind of like moving it aside. I'm like, this is not very useful for me. It's just going to slow me down. So the other next best thing is RAG. RAG stands for Retrieval Augmented Generation. And that's basically the idea that you want to only retrieve documents that are relevant to your query, put them in your context, in your prompts, and then it increase the size of your prompts, but at least anybody can do that. And these days, apparently, we have new techniques that are very close to how LLMs work, where you use vectors, and you try to figure out which one is the closest vector to your vector and stuff like that. I don't really know how that works, so I wrote magic here. But yeah, and apparently it's very good at reducing hallucinations. So if you remember a time not so long ago where AIs were hallucinating a lot when you were querying them, and creating links and creating references out of nowhere, apparently RAG is what fixed all of that. So that's what I started using, basically. And yeah, I started using that for my code base and started pretty much getting all the files in my code base, all the Circom files into my vector database. But the problem there, and so basically I would use the file I wanted to analyze, or the template I wanted to analyze, to query this vector database, and include like, I don't know, 5 relevant documents in my prompts. The problem there is that using code to query a vector database doesn't work that well. Usually you're expecting more like text, like manual queries. And when you query something, then you get an entire file, and so you might include the entire file, but only one function there is relevant. And so it kind of sucks. So I looked at what other people are doing, and a lot of these kind of talk to your code-based projects use RAG also. But they sort of do it differently. They try to use static analysis and chunking techniques to only include like functions instead of entire files. So I guess I tried doing that, and so I went back to static analysis, so it kind of sucks. So I have a fork of Circom to try and like export some stuff that's useful to me. But even then, creating a query from the text didn't work super well from the code I was analyzing. So I think I talk about that later, but I can tell you what I did now. I'm basically giving the code to an AI, and I asked the AI to create a query for me, which has worked pretty well. And so something I realized when I was using static analysis is that also with Circom I kind of lose the comments, which adds a lot of context, and also helped me create a query for my vector database. But also I don't really get the code. I get an AST, and reparsing the code from the AST was kind of a pain in the ass, and I didn't want to spend too much time there. So right now I use a mix of static analysis and grep, just to I guess static analysis just to understand the call graph, and functions and templates and stuff like that in Circom. And then I use grep just to get the actual code with the comments. And it works pretty well because Circom is pretty simple language. And then I was like, okay, actually I have all the code I need to get all of my call graph and the code that I need, so I don't really need RAG anymore. Why am I doing this? And so I kind of gave up on RAG, and I was like, all right, this is well, I didn't give up on RAG, because I'm actually still using RAG. But I was like, okay, I don't need RAG to actually query my database, my code base, because I already know everything. Oh yeah, and at this point, I realized that I'm trying to solve a lot of problems that have nothing to do with finding bugs or nothing to do with using AI to find bugs. It's just about querying a code base, creating a prompt with the relevant code. So I spent quite some time there. And yeah, so RAG is not dead because I'm still using it for relevant documents. So basically all my bug reports and guidance on how to find bugs, specific bugs in Circom, I embed in a vector database, and then I query that when I create my prompts. Again, using AI to create a query from the code I'm trying to analyze. And it also works pretty well, so I'm pretty happy with that, but there's a lot of optimizations to do there as well. The way you create embeddings for your documents, the way you create queries, all of these things is kind of another black box to open. Oh yeah, I guess I have an entire slide for that, but I don't know if I'm going to go over that. Yeah, I guess when I was trying to create queries, I was basically doing prompt engineering to figure out how to create good queries. And I kind of go over that. It's not super important, but in the beginning I would get very vague queries like, like bug reports on zero-knowledge proof circuits, lesson found for Circom security. And all my documents are about Circom and security, so it wasn't very useful. So I had to do some prompt engineering, and at the end I got some pretty good results. And then the cool thing is that I can actually use AI to understand why my results are not good sometimes. So if I get queries that are not good, I can ask, why didn't you include this keyword, or how can I change my prompt to include so that you would have produced better queries and these kind of things. But this is really prompt engineering. Again, it doesn't have much to do with like finding bugs using AI, or it has everything to do with finding bugs using AI. But yeah, I thought that was interesting. And just as an aside, like there's also a bunch of documents that I pull into my prompts without using RAG or static analysis. I just like, if there's like actually, how many people know Circom here? I guess I should have asked before. Okay, less than half. So in Circom, you have this arrow with a single dash, and there's also another operator with equal signs instead of these dashes. And this operator is well known because it doesn't create any constraints, which is bad for zero-knowledge circuits. So we have guidance on how you can find bugs when this operator is detected. Same as like other operator, or like the assert function doesn't create constraints, so it's pretty bad. Some developers don't realize that. So if we see an assert in the code that we're analyzing in the prompts, then we pull that document. So we do a lot of that. So just to recap, we use static analysis, we use grep, we use heuristics. I guess regexes or grep, or like whatever, and we do use RAG as well to create the prompts. So the big question is, does it work? As expected, it doesn't work very well. I have a paper, I have a slide on that after that looks at related work. And related work, basically, some of the related work or the papers that came out on finding bugs with AI basically says that the AI that we have now haven't really been trained on finding like these kind of things, like finding bugs or bug reports. And so when you test them on like benchmarks that actually test, can you find this bug? They don't perform that well. And so maybe there's a fine tuning or like a training issue. And so that's also something that, I think I should look at. But my whole idea when I started that was that, okay, it's not gonna work, but at least I'm gonna understand how to format the data that we have. Like we have a lot of bug reports and bugs that we found and that we didn't publish. For example, we have private reports and these kind of things. So we're sort of creating a database over time, but it'd be good to know like how to shape that data so that it's useful once AI get there. I think that's kind of the idea for a lot of AI startups out there is do something with AI right now that doesn't work super well, but when AI gets better, then your thing will work and you'll be successful. Yeah, that's pretty much what I said. And the other thing I realized is that it's pretty hard to understand how your stuff works, like if it's doing well. There is some benchmarks based on general, like the NIST has a test bed, but it's on general bugs. Some people are using CTF to like test if like AI is good at finding bugs. But it's very, like for the Circom stuff specifically that I was looking at, it's very time consuming to understand if something is a false positive and to understand if something is a bug. So far there's nothing that I tested really brought up something interesting, but it did bring up ideas that I could explore in the code base I was looking at, and so that by itself that was good. But there's a lot of, I think that's a problem with AI in general. It's very hard to understand if it's useful or not when you make changes and so on. All right, and the other thing that I cannot run into is that it's kind of expensive to use AI. So the OpenAI API is quite expensive. Actually, when DeepSeek came out, the price went down, so that was nice. And if I use local LLMs on my laptop, I can only use like smaller LLMs, like smaller LLMs with like smaller number of parameters, or distilled models. So distilled models I asked earlier, but they're basically you take like DeepSeek came out with like I think 700 billion parameters, so it's pretty large model. If you don't want to use that, you can train a smaller AI like Llama with like 7 billion parameters, which is like 4 gigabytes, and you can train it based on that bigger AI. And apparently it makes your smaller model better. But for me, I didn't really get good results. Like none of the smaller models really understood Circom, so I couldn't really work with them. But at least it was for free. And what else can I say about that? And also, I guess for some reason, all of that is expensive. Like these external AIs, like OpenAI or the DeepSeek service or Gemini, or they can be expensive to use. Actually, Gemini is for free, but it's rate limited. Or Claude can be expensive to use, but for some reason, if you use the app directly, it's for free, or like whatever is your $20 per month. So a lot of the times I just paste stuff there just to test variants of my prompt instead of paying for an API call, and that's a way to save money. Oh yeah, I guess I don't think you can read that, but yeah, that actually doesn't matter too much. Okay, more things in I don't know what order, but the Circom database I was looking at had many ways of like building, which was really annoying. It's not super related with what I'm doing, but I'm trying to automate things in a nice way. Like ideally, I want to just give like some Circom commands, and then AI can just do its thing, and I just have to sort of filter through it. I'm not sure if it's going to work with other frameworks, now that we've done all the work for Circom, but that is to be seen. There's a lot of, so as I said, there's a lot of false positive. So one interesting thing that I've done was to like ask an AI to like double check something, and so sometimes the AI will double check itself and say, oh no, actually that's not a bug. So maybe that's a good way to filter through the false positives. There's many ways, as I said, you can improve the embeddings, maybe that's a way, but I don't have enough embeddings right now. I have like maybe like 30 of them, so I don't think it's really a problem that I should solve until I have like hundreds of embeddings. And I need to do, yeah, it's always hard when I try something to understand how it performs across different models. So one thing to improve is like basically get the result from all these models and try to see if I can compare. But basically, a lot of my time was doing prompt engineering, trying to understand how I could refine these prompts, what models I could use, if I could use local LLMs or external LLMs. Even ChatGPT has so many different LLMs and they have a naming problem, so it's hard to understand which one to use. Oh yeah, that's a, yeah, I don't know if you can read. Actually, this one is pretty funny. But I asked some local LLMs if they can understand Circom, and they would make up stuff, and they really don't understand what's happening there. At least Star Coder was more honest. He was like, no, I don't know. So I would say that's better. But yeah, that's Mistral. Kotlana, DeepSeek R1, but a distilled version of it, 7 billion parameters. But if you ask if you ask the 70 billion parameter distilled version of DeepSeek R1, it actually knows Circom. So at some point it knows Circom, but if you reduce your model too much, then it doesn't understand Circom. So it must mean that they have used Circom to train their AI. I also asked OpenAI, don't use RAG, and tell me if you know Circom, and it said yes, but I don't know if it cheated or not. But yeah, if I use presumably if I use an API call, it shouldn't use RAG, so I asked O3, the latest O3, and it knows Circom. So I thought that was interesting. There's also a reasoning thing. I don't know if all the LLMs do that, but that's what O3 does that at least. And you can choose if you want low, medium, or high reasoning. And so we get different results doing that. And and one thing that we use a lot is use structured outputs. So we tell the AI use JSON, or like use this Python class to produce outputs, and like that we can quickly see if it's. So here I ask the AI to double check, and I have a positive field, and if it's true, it tells me it's not a false positive. If it's negative, if it's false, I know that it's a false positive. So I can quickly. I don't need to interpret the response of the AI to understand the output of the AI. So what was interesting when I was doing that is that I was sort of pipelining. I was creating a prompt, but I was asking AI to create the prompt, like for the embeddings. And then I would get a prompt, and I would ask an AI to do something with that prompt, and I would ask another AI to double check. So I was sort of like creating these pipelines of AI agents, I guess. And so it occurred to me, and that's probably not a very original thought, that probably all products that use AI are going to look like that. They're basically going to be complex machineries of basically transporting data between AI, from AIs to AIs, and trying to get a better and better outputs. It's kind of messy, but that's what was happening when I was playing around. It's not super important, but this is sort of what I ended up with. Maybe don't look at this too much, but it's a basically I have a command that initializes my stuff on a code base, so it's doing static analysis, grep, creating embeddings and stuff like that. And then I have an analyze command that I use, and then I can sort of like choose my own path, and I can choose from different local LLMs or external ones, which one I want to use. It creates a query. If I'm not happy with it, I can modify it or change AI, and then it goes to the next step and so on. So I have this kind of a pipeline that works well. But when I looked at that, I sort of realized that it's a very like single shot thing. Basically, I'm creating a big prompt at the end, and I'm checking if it works. But there's different approaches. So today, that's what I have basically. But there's a different approach, which is to. Well, actually, maybe there's another approach that's easy. But instead of just asking the AI to find bugs, this is really a prompt engineering thing. But I can ask the AI to explain what the code does and to find holes in the explanation. So there's different approaches in terms of prompt engineering that you can take. But in terms of architecture, there's this autonomous AI agent strategy, which is to basically, don't read that again, but it's basically to ask the AI to loop over itself, and to basically tell the AI, okay, find bugs in this code base, you can call these functions. And basically the AI will call these functions to like retrieve code from the code base, to retrieve, like to do some RAG, to retrieve documents from a vector database. And so you can interact with the external world, or your local world, I guess, in some ways. But basically it keeps on going until it finds a bug somewhere, or until it says, okay, I spent enough money here creating AI, so I'm going to stop. And so that's an interesting approach. That's probably what I'm going to try next. The problem is that it gets very expensive if you don't have your own AI. Like if you have your own AI, the time it takes is kind of the bottleneck. The money you have is the limiting factor. Right, this is the related work. As I said, there's some people talking about the fact that it's hard to test things. When you test AIs to look for bugs, you realize that they don't perform well. And the other stuff I could find, basically I have this kind of autonomous AI agent strategy where, mostly because they're like looking through a network or like they're trying to hack a machine or this kind of thing, so they have to interact with the terminal or they have to make queries over the network. So they're kind of forced to have an autonomous AI agent. But that's, in our case, we can do a lot of things with a single prompt, but I think it's still interesting to take this autonomous approach as well. Right, I just want a nicer web UI, but that's just for me. Okay, maybe this is interesting. You guys can tell me if that makes sense, but my dream or my vision is like you place this YAML file in your code base, anywhere in your code base, and it tells me the command to run, the Circom command to run. And then I detect it. Whenever you push on a certain branch, I reinitialize the project with the code base, static analysis, embeddings, whatever. And then you have a web UI where you can like analyze specific functions, get reports on the code base and these kind of things, and then we're rich because you'll pay us for that. And maybe that makes sense once AI gets good enough for that to be. Because I'm not going to have a job, presumably, when AI is going to be good enough. So, yeah. Oh, okay, I guess a recap. I don't know how much time I took.
Give it another 5 to 10 minutes.
Oh, okay. So maybe questions if you guys have any. But recap is there's different dimensions in this. So I said it doesn't work well, but it gives me interesting results, and that was a really fun project, and it gave me some kind of some hints on what I could look at in the code base I was looking at. I think I can improve a model. I'm wondering if I should actually fine-tune a model on Circom or like bugs of Circom and like maybe get interesting results there. I can improve RAG, but as I said, I don't have that many documents right now, so I don't know if it's a good time to do that. Prompt engineering, there's so much to do there. It's really not clear how things change as you change the prompt, so having a better interface for me and my team to like play with that, I think would go a long way. And yeah, so right now what we have is this kind of many steps approach where we list. So I have a list function that tells me like, maybe I didn't talk about that, so I'll talk about that now. But I give the whole code base to an AI. So this is where I need like a large context window, like Gemini is a million token, and it will tell me what functions I should analyze. And then I can analyze specific functions or templates in Circom. And then once I analyze them, I can ask an AI to double check. And now that I'm thinking about that, I'm thinking about another thing that I wanted to write in the slides that I forgot about. I could also technically ask the AI to create a proof of concept and to try to exploit the bug. But that's kind of next level, and it's not clear how well that's going to work, but that's something that we could do also. But yeah, it's hard. I guess when I wrote hard here, I had that in mind, but I forgot the actual keywords. Cool. Okay, that's it. If that sounded interesting, talk to me. If you thought I said some dumb things, also talk to me, or if you have some ideas for me to explore, talk to me. And if you're not following me on Twitter or x.com, I don't know what you're doing, but you should fix that. And yeah, that's it. Thanks.
Take a couple questions?
Sure, if there's time.
Yeah, we have maybe 2 or 3. Maciej?
So I guess I have like 2 shorter questions. But the first question is, do you find it relatively often that an AI just is like eager to please and it's like, hey, do you have a soundness bug? And it's like, you give it like the perfect code base and it's like, yeah, here's a soundness bug, and you're like, not quite? Or is that less common than that?
Yeah, the AI being eager to please, actually I really like. I like that the AI never says no.
Yeah.
But in this case, it's kind of annoying.
Yeah.
So when I started with like, give me at least 2 bugs, if any, the AI always came up with 2 bugs.
Yeah.
And so I think that's where the double check please is interesting, because that's another opportunity for the AI to say, yes, there is no bug. And that's like I'm using that against the AI. And so it always finds a bug, but when I try to double check it, it sometimes will say, no, that's not a bug. So that's why it gets interesting.
Okay. And then the second question was, do you sometimes take previous audits you've done or like handwritten examples where you introduce a bug and just give it to the setup that you've created to see if it'll detect the stuff that you've added in?
Right. So do we create
Like test
data
cases or something like that?
to try to basically to give more examples, like data that would be good at training an AI, basically, right?
Yeah, or even just testing to see if the AI is actually working the way it's
Okay, so so we're not doing it to test, but I think that would be the next step, would be to like create bugs intentionally and give it to the AI to like see when we change something, how many does it find, how many does it doesn't find, and these kind of things.
Okay.
But that's a good idea, and but it's really time consuming to do these things.
Oh, yeah.
Yeah, cool.
Thanks.
Do you feel RL can also help you?
I said that again?
Reinforcement learning can help you?
Brain.
Reinforcement learning?
Reinforcement learning. So you mean like fine tuning, or is that
It's not fine tuning, it's like repeated, like on the basis of some reward function you are training.
is that just training?
Yeah.
Oh, well, yeah, it'd be interesting to see if we could train. So actually, I'm not sure what's the difference between that and fine tuning, right? Like when you're fine tuning something, you take a model that's been trained, and then you're trying to continue. If I understand correctly, you continue to train it on data that matters to you, and so that's where we could like have a better model for what we're doing. But we probably wouldn't start from scratch. We would take an AI that already understands Circom, or does that make sense?
Yeah.
I don't know. Or maybe I'm not understanding these things enough. One last question?
This meal's actually going to be 10 minutes late, so if we have more questions,
right.
then if this works for you.
Is that a 10-minute question?
Alright, I can come up with did you have any issues with the models being neutered and like not willing to like help you exploit code?
So when I ask, like, can you give me the recipe to create a bomb? Like, usually that doesn't work well.
Sure. Yeah.
But for these kind of things, though, like, it's happy to find bugs. And
Yeah, there's been times where I've asked it to do reverse engineering and some of these things, and it's been like, I can't help you with that.
was it like a?
It's like I kind of have to coax it into getting in the mood to do some reverse engineering. I can't just be like,
Interesting.
do it.
I'm wondering what you were trying to reverse engineer. Was it
Just
ethically
various
wrong, or?
things, you know? What's a bomb? No.
Yeah, interesting though.
Okay.
How far do you think you are from AI, or whatever you have built over here, becoming code flows for you or your team?
I think actually right now it's already useful just to like, the lists thing that tells us like what function to look at is interesting. I mean, AI is already super useful by itself, right? Like we use it like just explain this code, what does this code do, or convert this code like in some other thing that we can use. So we already use it a lot. If on open source code, right? If it's private code, we try not to use it, or local LLMs. But this is from like, I did this last weekend, so we're not using this yet, but I'm hoping that we're gonna improve this and basically include it in all the audits we do until it actually becomes really useful for us. I don't want this to take time away from the audits that we do, because it's pretty time consuming to do an audit by itself. But I also don't want to like lose the opportunity to. We spend a lot of time like creating these reports and understanding this code. So if we can use that to create embedding, like documents to guide AI, or bug reports in the correct shape to guide AI, then it's better to do it now rather than do it in 3 years with like 1,000 documents, and that would be horrible to do. So yeah, we're not using it yet, but I want us to use it as soon as possible.
Do you also feel LLMs can detect the new bugs?
The new
bugs which never happened before?
So what do you mean? What happened?
Like maybe like there are a lot of bugs existing in the market, right?
Mm-hmm.
Where you can also do the fine tuning and all, right? With the existing report and
Oh yeah. So yeah,
do you feel LLM can find the new bugs which never happened earlier?
Oh, so like, so are you saying it's good at finding similar bugs, but if there's a new bug that has nothing to do with all the stuff?
Yeah.
Yeah, so I think that's the real question, is like, well, that's the question in every field that demands a bit of creativity. I know like mathematicians were asking that, like, can you create anything new? And I feel like we have sort of the same question. It's like, can it find bugs that are not like any other bugs that were found previously? And part of me wants to think that circuit bugs are like any other bugs. Like there's nothing, like, or basically every bug is the same as the previous bug. Like there's no creativity in a bug. But parts of me think that every time I find a bug, it's something that looks very different from anything I found before, usually. And so I'm wondering if an AI would have been able to find it if it knew all the bugs that I found before.
Then in that scenario, what's the advantage of the LLMs? You can just make some proprietary algorithm.
The first advantage is that we can use it to find bugs that we found in the past. Like if it's good at doing that, at the very least we have this database of bugs, and we can find low-hanging fruits or easy bugs to find, or bugs that we found in the past, and these kind of things. Or maybe we can sort of use it to, if that doesn't work and it doesn't find the complicated bugs, at the very least we use it to like understand complex code and how to navigate it, and what area has more chance of having a bug and these kind of things. So really as a tool, not necessarily as something to replace me, but as a tool to make my job easier.
Do we think LLM can replace, LLM-based audit can replace human audits? What do you think?
Well, we'll see. I guess, I think that's really the day. I think that's my answer, is like the day where AI is able to create new theorems in math or something like that. I think for sure they'll be able to like find new bugs and these kind of things. But I don't know if the contrapposite is true.
For the ZK lab, do you see a lot of people joining your AI ZK labs? And what do they expect from you, and what are you?
Oh, the AI ZK labs? Oh, that was just a joke. we're not creating that.
No, when you post it on Twitter,
right,
people actually send you a DM and ask to join your labs.
Yeah, I got like 10 DMs on that, I think. Either people that wanted to invest in it, or people that wanted to join it, or collaborate with it. So collaboration was usually pretty nice, because oh, you're interested in these topics, okay, so it's not the end of the world. But if you want to invest in that, I don't know why. And if you wanted to join, I think it's just based on the keywords.
I want to understand the performance of finding the bug when you use like GPT-4 versus DeepSeek R1 versus O1 versus O3. So how is the graph going, and what is the difference for these models?
So that's the part where it's very subjective, because I didn't really get good results with any models anyway. But I did feel like O3 with like high reasoning yield the best results. And for some of the stuff I was doing, I had to use Gemini anyway, because I needed a large context window. So I don't have a good answer. Basically, the large context window is very useful, and it's kind of a shame that ChatGPT doesn't have that. But in terms of pure result on like smaller prompts, then it's not super clear.
Do you think the graph is going upwards? Like in future, we'll have better models, better reasoning models, and which will be able to at least find out these smaller bugs, the smaller context.
Oh yeah. So that's the whole idea, is to create something that doesn't work now, but as soon as the model gets good enough, it'll magically we'll change the model to the new model, and everything will work and will be rich and successful. Yeah, we'll see.
I had a question. You mentioned grabbing the Circom and wanting for like a YAML that would describe what Circom commands to run. It made me think of like projects for SDKs or libraries that have a lot of tools to generate documentation for them. And you might want something that makes your code base interpretable to AI better. do you have a sense of like what would be useful there?
So I don't know if it's too. So when I was reading about the RAG stuff, to like a lot of these chatbots project, they use RAG to let you talk to a code base. What they were doing is that they were like taking chunks of code, and then they were using AI to describe create documentation on each function in the code or like constant or like whatever, and then they were creating documents to embed based on that. So I guess they basically were doing what that for the embeddings and like use that at this level. I don't know how useful it is, and I guess I also talked with them when I was asking AI, can you explain that code and then can you find holes in your explanation? So instead of like looking at the code and finding bugs there, you let the AI explain why the code works, or like what's the, like we're looking at things like non-native arithmetic or big implementations. So how is this thing implemented? Like explain that. And then in your reasoning or the documentation that you created or the explanation, find bugs in that. And I don't think it yields better results, but I thought that was an interesting approach. So yeah, up in the air. I think we should basically experiment with all these approaches until we find real bugs, and then we can see which one. Or like this idea of benchmark that we talked about earlier, like see which one are do better once we have like a real testing framework.
I have one more question. Did you experiment with toolies at all? Like, did you try giving it a Circom runner and like being like, write this Circom code with or without the bug and run it and like see the result and then iterate?
Yeah, I thought about that, but I was like, so I was looking at a function that's, a lot of the tests I was doing was on a pretty complicated function, and I was like, I think it's gonna have trouble trying to, maybe I could like give it like a JavaScript framework rather, like, so you can create a test or create an exploit. I don't think just giving it Circom would be useful, but maybe like a JavaScript framework to do that. But I haven't experimented with that, but I think that would be very interesting. And so basically like, okay, create a proof, find an exploit and create a proof of concept, then run the proof of concept. Oh, it doesn't, this is the output. Are you satisfied? No? Okay, try to fix your proof of concept. Do you want to give up, or do you think your proof of concept can be fixed? And maybe there's a flow like that.
Yeah, you could maybe automate it like writing the Circom kit test. Be like, here's Circom, write the Circom kit test.
Oh, yeah.
Now run it in JavaScript, see if it breaks. Okay, now iterate on that until it doesn't break. Yeah.
Right. I mean, at the very least, we can give you like an example of how that would work, but yeah. Cool. But yeah, AIs take a long time. Running Circom takes a long time. That's an interesting, but I mean, we can think of a future where we analyze a code base by pushing a button, and then a few days after it returns a report. And, but it's expensive.
Probably cheaper than the security engineer.
Yeah, that's true also. Cool. All right, should we call it?
Yeah, all right, thank you so much.
All right, thank you.